So let's now look at the effect of knots on strength. Knots are very commonly used as grading indicators, as strength indicators on full-size timber. And because we think that knots are points of weakness because of the fact that they cause deviation in the grain angle, and also because in the case of dead knots, there is no mechanical connection between the knot and the wood around it. So there are a few ways in which we might describe the size of the knots. We might measure the dimension, the diameter of the knots on the surface, or we might project how the knots are inside onto the cross-section and kind of estimate how much of the cross-section is occupied by the knots inside, and infer then that the larger the knot area ratio, KAR, the lower the strength. And it sort of works, but not exactly. So it's useful. It's very, very useful. So if we plot strength, bending strength of full-size timber versus knot area ratio, and knot area ratio, which is the size of, or the amount of the cross-section that's taken up by the knot, that can vary between 0 and 1, as 0% of the cross-section occupied by knots, that's clear wood, and 100% of the cross-section occupied by knots, that's fully knot. So you would then expect that the ones that have many knots have low strength, and the ones that have no knots have good strength. And it's certainly the case that if you have large knots, it's very rare that you have high strength. But it's quite common that even if you have no knots, you have low strength. So you end up with a distribution or cloud of points that looks something more like that, and quite a low coefficient or correlation coefficient of that relationship. But it is useful because it tells you if you have high knot area ratio, it's unlikely or more likely that you have low strength pieces than high strength pieces. Now, this is not necessarily because of this assumption that we have that knots are causing deviation in the grain and are not connected very well to the wood around them, although they are part of the puzzle, undoubtedly. The reason is that you can have a piece with a knot in and have quite sensible growth deviation or grain deviation around that knot, because of course in the living tree, the tree has done a sensible job of putting the grain around that knot in order to hold the branch. The branches were heavy, so the tree has done a lot of work to make the point at which the branch is connected quite good and strong. It only stops making sense when we cut the wood into rectangles. But depending on how we've cut it up, we might end up with a knot that causes such a strength defect, or we might end up with a knot that's not actually causing much of a strength defect. And telling those two apart is quite hard and perhaps even impossible. There are lots of people who've done very sophisticated models of knots and used finite element analysis and so on, and still had not much success in actually using knots directly to measure strength. And actually, one of the reasons that knots work quite well in timber grading is not because of how the knots are in the timber. In fact, if we had another piece from the same plank and we just cut it off and it had no knots in it at all, the knots in this piece might actually be quite predictive of the strength of this piece with no knots in. And you might think, well, how is that possible? Well, the reason is that knots are indicative of growth conditions. If you have big knots, that's indication that you had big branches. If you have small knots, that's an indication that you had small branches. Trees that are crowded, that are next to other trees, tend to have small branches, at least the softwoods. And trees that are crowded will grow differently from trees that have a lot of room around them. And therefore, the size of the knot is an indication of the growth conditions, and it's growth conditions that are affecting mechanical properties. So knots are a sign of strength, but they're not necessarily a direct link. It's not that necessarily knots cause low strength. It's that if you see big knots, that's an indication of growth conditions that are linked to poor strength. So that's kind of how knots end up being a useful grading parameter, and it not necessarily being the case that it's directly causing the timber to be weak. So you can have a piece of timber with big knots in it and it be strong.